differentiate between a definite and indefinite integral. Now, guys, a definite integral is an integral whereby the limits of integration have been given, i.e., e.g., if I have an integral from 1 to 2 of some function f of x dx, this is a definite integral. And if I am to represent it using a drawing, then it would be if this is my x-axis, this is my y-axis, then let's say my function of x is a curve like this from 1 to 2. Then the definite integral represents this area. For the indefinite integral, this is an integral whereby the limits are not defined, i.e., you're just told integrate f of x dx. You're not being told from which point to which point. So in a diagram, it could be, this is your function of x, and you're integrating it indefinitely, like there's no starting point or ending point of your integration. So those are the definitions for definite and indefinite integrals. Then the next question, question number 2, evaluate the integral of cos x over 2 dx. Now, this can simply be written as, this can simply be, just a minute. So this can be written as integral of cos a half x dx. Integral of cos a half x dx. And guys, recall, if you integrate cos x dx, what do you get? The integral of cos x gives you sine x plus c. So here we have our constant a half, which is here. And recall also from the table of standard integrals that I gave you, if you integrate cos of ax dx, where a is an arbitrary constant, what do you get? You get sine of ax over a plus c. So in our case here, if we follow this, then our integral will be sine of a half x over a half plus c, similar to what we have in the standard integrals. And we can write this properly. Sine a half x divided by a half is the same as 2 sine a half x plus c. And this is the answer for the second question. So for question number 3, this is the question. The integral of x 1 plus x cubed dx. The integral of x 1 plus x cubed dx. Now, guys, before you even start thinking about using substitution to integrate this, why don't you just open it? You can open this bracket so that you have x plus, and then this other one, x to power 4 dx. Then now integrate. If you integrate x, you get x squared over 2. Plus, if you integrate x to power 4, you get x to power 5 over 5 plus c. And that is the answer for number 3. I hope we are together up until that point. If you have a question, please write it in the chat box. Number 4. So number 4, the question is integrate t raised to power 4. And then here we have 3 minus 5 t to power 5 dt. That's the question for number 4. Solution. Now to integrate this clearly, look at what we have here. We have 3 minus 5 t to power 5. If you differentiate t to power 5, you'll get t to power 4. So the best way to go about this is through substitution. I'm going to write it in a much simpler way. Let me have this as t to power 4 and 3 minus 5t, all this raised to power a half dt, because the square root stands for power a half. Then let u be equal to what is inside the bracket. That is 3 minus 5t to power 5. Then I am going to use the substitution u. So I will be replacing with u. Now, what is my du dt? If you differentiate this function, what do you get? Derivative of 3 is 0, minus derivative of 5t cubed is 25, t raised to power 4. So I want to rewrite the whole of this question using u now. Let's see how it transforms from there. So we will have integral of t raised to power 4, u raised to power a half, where there's the whole of this function, we've called it u, so we put u raised to power half. And then where there's dt, we replace with this. Du dt is this. So what is dt? What is dt? If you make dt the subject of the formula, du over minus 25t to power 4 will be equal to dt from this here. If you make dt the subject of the formula. So instead of dt, I will write the whole of this, because we are transforming the whole question to du. So du over minus 25 t raised to power 4. This t raised to power 4 and this t raised to power 4 cancels out, so that you remain with integral of u raised to power a half du. Now we can easily integrate this one now. U raised to power a half, if you integrate it, what do you get? You get u raised to power a half plus 1, that is 3 over 2. All this divided by 3 over 2 plus c. But u was just a substitution that we introduced so that our question is simplified. So write back u to what its original value was. And this is it. So my final answer will be, first of all, let's write this in a better way. U raised to power 3 over 2, divide by 3 over 2 is the same as 2 over 3 plus c. So 2 over 3, my u is 3 minus 5, t raised to power 5. All this raised to power 3 over 2 plus c. And that is my final answer. What about minus 25? Minus 25, okay, sorry, minus 25 is there. I'm the one who's left it out. Thanks for the reminder. So we have 1 over minus 25, 1 over minus 25 here, 1 over minus 25 here, and finally here also 1 over minus 25. So if we put that, our final answer becomes 2 over 75, there's a minus here, then 3 minus 5, 7 t raised to power 5, 3 over 2 plus c. That's our final answer. Let me know if you have a question. Now, guys, we said when it comes to partial fractions, then the denominator is what we consider. Now, the denominator can be linear, it can be quadratic, it can be repeated. Now, looking at this is actually a difference of two squares, which I can simply write as integral of 1 over a minus x, a plus x dx. If we open this 2 up, then we will simply just get this. And when you open it up like that, we clearly see that it is linear. So resolving it into its partial, we will resolve it as linear. So this is what we are going to have. I'm going to have 1 over a minus x, a plus x. And then I want to resolve this into its partial. So this is going to be, I can rewrite this such that we have it starting with x. So the first one, take out the minus. So that, let's take out the minus. I want us to start with positive values of x so that it becomes easier to relate. So taking out the minus, we have minus a plus x. For this other one, and okay, so I've actually seen that if you take out the minus, it's going to affect this other one. I wanted to make both the x's positive. But anyway, let's just go on and evaluate it the way it is. So if we are to open this up using partial fractions, so this is going to be equal to 1 over, and then this is also going to be equal to, this is easy because we've dealt with this before, where you're having x, let's say, plus 3. How do you open it? You just open it with your x plus 3. So here we will have our x plus a, or a plus x. And then on this other side, we will just have a minus x. So putting this under the same LCM, then we will have a minus x, a plus x into, how many times does a minus x go here? A minus x, we will have a plus x here, plus how many times does a plus x go here? We'll have a minus x. So what does that give? A and a will give us 2a, x minus x will give 0. So all this divided by a minus x, a minus x, a plus x, a plus x. And this is supposed to be equal to 1 over a minus x, a plus x. Now, clearly, what we need to do is now, since this denominator and this one are equal, compare this to this and determine what exactly we will get for our a values. Let's see. Just a minute. Okay, guys, so I want us to go over it again. It was supposed to be, if we resolve this into partial, it's supposed to be actually a over a minus x plus b over a plus x. That's how it's supposed to be. So we will be looking for the values of a and b that make this actually possible. So if we come here, putting this under the same LCM, then we will have a minus x into a plus x into a minus x goes here, a plus x times, plus b into a plus x goes here, a minus x times. And then we are supposed to equate it to this side, 1 over a minus x, a plus x. That is it. So now we want to look for the values of a and b. So we are going to assume different values. So when x is equal to, so let's say x is equal to 0. When x is equal to 0, what does the equation translate to? On the upper side numerator, we'll have 1 being equal to x is 0. So here we will have a plus x is equal to 0. So here we'll have ba. Then when x is equal to, let's say, 1. When x is equal to 1, so what are we going to have? When x is equal to 1, we'll have 1 is equal to, so when x is 1 here, we will have a plus a. When x is 1 here, we will have, no, let's say when x is a, so that it gives us something more simplified. Instead of 1, let me use a actually. When x is a, because x can be any constant, so let's use a. When x is a, what are we going to have? So 1 on this side. When x is a, we are going to have 2a. So here we will have 2a. When x is a here, a minus a will give us 0. So the whole of this will disappear. So from here, what we need is the value of a and b so that we can be able to rewrite this. So from here, we can clearly see that a is equal to, making a the subject of the formula here, we have a half, or 1 over 2a is equal to a. And then here, what is our b? So we can write this as 1 is equal to a into a plus b. Okay, But we already know the value of A here. So I can have this as 1 is equal to A into, the value of A is 1/2 plus B. So make B the subject of the formula so that you can also get the value of B in terms of A. So what will B be equal to? 1, this and this will cancel out with this when you open the bracket so that you remain with 1/2 there, plus on the other side we will have BA. So 1 minus 1/2 is equal to BA. So 1/2 is equal to BA. So what's the value of B? Make B the subject of the formula. Oops. Making B the subject of the formula, then we will have B is equal to, so divide by A. So 1/2A. That will be the value of B, and our value of A is here. So coming back into our question, so we have the value of A and we have the value of B. Coming back into our question, we say that if you were to write it into its partial, it's going to be A over A minus X plus B over A plus X. So what is our A? So 1/2A over A minus X plus 1/2A over A plus X dx. This is what we are supposed to now integrate, which now should be very simple because we, in both cases, we just get ln, i.e. when I'm integrating the first one, what about when X is equal to A and X is equal to minus A? Now, guys, that should also work. You're going to be logged out of this meeting, so I request you join using the same link.